Hello, my name is Gabriel Sedano, and today I'll be doing yet another video regarding the office hours for CISP 400. Yesterday, I got to learn and review more about pointers, templates, classes, constructor and destructor methods, as well as file flags and stringstream objects. So, to begin with, I will be speaking about pointers. So, as the name implies, pointers point to things. So, generally in programming languages, pointers specifically will point to variables that are defined by the programmer. In C++, these pointers are made using the asterisk in front of the data type and behind the name of the variable. When using pointers, you can either point to something, again, a variable, for example, or you can use that pointer and dereference it, thus getting the value of that variable. When you set a pointer, what you are really doing internally in the computer is pointing to the location of that variable or thing in the memory of the computer. More specifically, pointing allows to point to the hexadecimal address in memory. When wishing to retrieve what that thing in memory holds, we need to dereference that pointer. In order to dereference that pointer, after setting up the pointer, we use the asterisk again to access what is in memory. I will scroll down to share an example. So beginning from line 125 of my program, this will all handle code regarding pointers. So to begin with, I previously defined a pointer using the pointer notation, and I set this to the address of x. Thus, when I output what is contained in that pointer, I am really outputting the address of x. When I wish to get the value of x, I use the asterisk to dereference. In programming languages, you may also use pointers as arrays, since internally, really arrays are identical to pointers, in the sense that arrays hold the memory in sequence of what they contain. Arrays are essentially pointers in that the name of the array itself points to the first thing it contains, and then the rest of the elements go in sequential order of that memory address. So say, for example, the memory address ends in 62, then the next elements will be 63, 64, and so on. Their addresses, specifically. So here, I am setting up a pointer called array, or named R, and I am setting it to a raw pointer, but using this keyword new. So I allocate memory for specifically 5 elements for an array that will hold integers. Using a for loop, I will fill this array with numbers, the index multiplied by 5. Note that unlike regular arrays where they use regular use of arrays where one might tend to access the elements by using brackets, because I am treating it as what it really is, a pointer, I first use the pointer notation, the asterisk, then I enclose this in parentheses, and I write r plus I. In this program, the r refers to the first element of that array in memory, and I will go through that memory. Afterwards, I will be outputting the result of that array. Additionally, you can also have this sort of arithmetic with pointers. Pointers aren't just these non-interactive things that only do one or two things. You can also add to pointers, and you can also increment and decrement pointers. You can even dereference what the pointer has and add to it. So, to show the first result of my program in the console, the hexadecimal address of x is this address. The value of x is 10, which is what I defined it. And the array has 0, 5, 10, 15, and 20 based on that for loop. And then as a result of these lines in code, in the source code, I have these results. Now let's talk about templates. Actually, let me take a step back. Let me first talk about classes. So in programming languages, the purpose of classes is to hold both these variables that we're familiar with and these functions, which for the purpose of talking about classes, I will be calling them methods. So classes can have both these variables and methods, and you can choose whether to make them public or private. These private and public keywords determine the scope of what it contains. So as their names imply, if I set something to private, I won't be able to access this normally, in contrast to if this were defined in a main function and I just declare them. I won't be able to access them normally. If I set these to public, then okay, in main, I will be able to use these methods, and I will be able to process the information that these methods return. So for example, in this class test, I have a variable named x, a variable named y. I also have methods in public. This first method is a simple parameterized method, a parameterized constructor. I also have these accessors set x and set y, and one other method to print out what the class contains for its variables. Okay, excuse me for the small pause. In main, I begin by declaring an object of class test, and I am setting x to 5 and y to 5. But then I use these accessor methods to then change the x value to 10 and the y value to 20. Note that instead of deciding to use these accessor methods on separate lines, because these methods all pertain to the object, and because using this period is simply telling the compiler, oh, after this object, I wish to use the method, I can still continue to use different methods on the same line provided I keep using this dot. Then I can output the data in that class using the object's print method, and then I can stop the program. So here, as you can see, even though I declared the object with the first argument being 5 and the second being 5 as well, it turns out that after some processing, the object now has its x value being 10 and the y value being 20. Now, another example of classes I have is bank account. In bank account, instead of having a parameterized constructor, I have what is called a initialization list constructor. In bank account, I first begin by writing the names of variables for parameters that it will accept. Note that these are not the same names as the variables that are contained in private in the class. Then I use the colon to access the scope of what is really already contained in the class, but remember that this is private, so I need this scope. Then, as the name of the constructor implies, I begin a list of its variables, and inside these winged brackets, I give it the values that the constructor will receive. Additionally, in initialization list constructors, I can also provide another statement besides the variables that will handle output as well. So, back to main. I have 3 bank account objects, Gabe, Ben, and Will. These objects have different names, different ID numbers, and different dollar amounts to their names. So once I call these objects, what should appear is that because I am using the initialization list constructor, and because this constructor provides a statement to process information, I shouldn't have to provide code on line 174 to output it. So I will stop the main here, and I will run my program. As you can see, in this new bit of my console output, I am displaying the information of each object that I defined in order. So in that regard, initialization lists are very helpful in immediately providing both information and also possibly outputting data. Let's move on now to templates. So templates essentially are classes as well. They also contain variables. They can also contain variables. They can also contain methods. The usefulness for templates in C++ is its flexibility for data types. The templates allow for this flexibility of data types by allowing for any data type to be included as an argument. So when you state a template in these angle brackets, you can, when you write type name, this keyword will indicate to the compiler, oh, the programmer or the user can put in their own type or class in place of this argument. Then, with T being defined as any type name, I can also use T for the arguments to indicate that the type of data type of these arguments can also be any data type. Here, my function called mymax will accept any data type for these two arguments and return the largest. Once again, I will be going down to the main and setting a return 0 here so we can output one more new thing. And as you can see, 7 is returned. Likewise, I can use strings. In the program source code, I have trees and apples. And so the program returns trees as the result. Additionally, I have a template that does bubble sorting. Bubble sorting is a sort of linear sort for arrays where you make sure to give it just enough passes to be efficient in making the entire list ordered. And in this nested for loops, what I have here for the first for loop is the actual processing of that array, where on each pass, this will compare the first index and the index right after. Then in this for loop, I will also be outputting each pass that the function makes. So let me write another returns 0. Note that in this chunk of my source code, I have integers. As you can see, I begin with 10, 50, 30, 40, 20 in that order. And so this is the result of this bubble sort. I can also use strings, since this bubble sort is using a template. And here's the result. Now let's talk about file flags. When you begin learning about file input and output, you may be first familiarizing yourself with how to manage files, or specifically how to find and open files for input and output, for respectively for writing. Input being for reading and writing for output. File flags allow you to manipulate the manner in which you are inputting and outputting. So, I suppose I want to make up a file and save it in Replit. And suppose this file already has information. If I were to not include this file flag, iOS : app, I would be rewriting this file that I want to make. If you do not include iOS : app, you'll possibly lose vital information in your file. This flag appends to your file, which is to say it adds to the end of the pre-existing file, hence app in the name of the file flag. If I go to example, once I run this program once more, you can see that it doesn't just have one writing this to a file, it has two. As you can tell, I have been running this program a few times after removing the return over here. And so after removing return, because I ran this 2 times total, this has 2 lines that says writing this to a file. Note that because of the file flag being append, I have written this after the next line. Sorry, the previous line. All right. Lastly, but not least, there is the matter of stringstream. What I have just done is filestream, but I will go into another replit, and this works with input stringstream and output stringstream. Stringstream objects solely focus on strings. The usefulness of these stringstream objects is in reading the strings and assigning the content to variables of your choosing. Stringstream also accounts for whether the information in the string is an integer or a double or a string. In this example, I have an input string called A, and I am setting it to a string where called 3 space 2 space 5. I am then making this into a input stringstream object, and next I have 3 defined variables, all integers. Once this is streaming into the stringstream object, this string over here, I can then read from that stringstream object and input into these 3 integer variables. So once I run this program, what I should see is after the stringstream object inputs data into these 3 variables, I should be able to see them in sequential order because of the manner in which I wrote the lines. Three, 2, 5. That's good. What I can also do is use output stringstream objects. For the sake of this video, I will be deleting this for clarity. Okay. And removing this. Okay. For output stream, this is generally what stringstream does. And so suppose I have a function called countWords. And so it will receive a string. I will be turning this into a stringstream object. And what I can do is stringstream objects have simply keep on functioning until there is no more string to read. So because of the nature of that stringstream object, I can write a while loop, and this is legal. So while the stringstream object continues to receive data, it will output into word a string. And while this continues to run, I will be incrementing count. At the end, I will be returning count. Here I have my main, And so the string that I wish to consider is geeks for geeks. Ideally, I should be able to get the number of words in this string. If we count, this is 6, so I should be able to receive 6. I run this, and there we go. Last but not least, definitely last but not least, is the concept of scope. Now, before my office hours, I thought that scope was simply how far the program reads a variable. That's not necessarily really true. So, really, what scope is simply put, it is the variable existing between the brackets of main. So, suppose we go back to our original program. In this main, I have defined and initialized several variables. So the scope of these are main. They share the same scope. When I make or declare or initialize variables in loops, this scope is restricted to those loops. Slightly likewise, when I declare variables in methods, say for example this method in test. No, forgive me, sorry. Okay, bubble sort. So I define and declare variables in these nested for loops, but these variables, their scope is restricted to these loops. Once I run my program, all of these variables and values will appear. And once the compiler finishes the program, once I reach this and very last bracket of main, all of these values and variables will stop existing. That is the use of the word scope. I hope this video helped to clarify a few programming concepts. Thank you for listening.